Hey guys, it's Miss Kennedy. We are going to work on Encounter 1 for Unit 2, okay? I have a feeling that the board behind me is going to be backwards. So the photograph that is underneath this in Edmodo, you might want to bring up the JPEG so that you can look at that and run the video at the same time so that it's not backwards, okay? But hopefully my words will help you out. All right, so glad you're here. And you know you wanted to watch me over the weekend. I know. All right, anyhow. All right, so what Encounter 1 is all about is types of energy. Really what the big deal is energy is any form of work. So right, Miss Kennedy right now is definitely expanding some energy, having a conversation with you or the computer, okay, at this point. So energy, there's two types, kinetic and potential, which you all are really good at this point. You can say that kinetic is the energy of motion, while potential is that stored. Okay, let's talk about potential stored energy. It comes in two different types, really. Gravitational potential energy and electrical potential energy. Gravitational deals with height. Miss Kennedy does not have a lot of gravitational potential energy, okay? Anyhow. Elastic potential energy has to do with stretching, okay? Stretching are actually compression, so think of a spring, a trampoline, okay? Both of these, you can have an increase or a decrease of electric or potential energy at any time or gravitational potential energy, okay? Important things to remember about potential energy. The stored energy is dependent upon three things, and I always remember it as PCC, position, condition, or composition, okay? So where it is, the condition, the surroundings around us, and composition, what it's made of, okay? So the three things right there, okay? Let's talk about kinetic energy. Kinetic energy has to do with motion, okay? So the more you move, the more kinetic energy you have, all right? So the big thing with kinetic energy is it's dependent upon mass. The more mass you have, the more kinetic energy. So, for example, think of a building. All right, if you had a small cheetah, or a cheetah, any type of cheetah, run into a building, is it going to knock the building over necessarily? I think it's going to hurt the cheetah, actually. All right, but say you had a tractor trailer, and the tractor trailer is going the same speed, okay, or a big old tractor, the same speed as that cheetah. Who's going to make the biggest dent, the cheetah or the tractor trailer? The tractor trailer is, definitely. At least it's going to make a dent. Poor cheetah, I don't know what's going to happen to it. All right? All right. So the more mass, the more kinetic energy. Okay? Hopefully that's good so far. When you have both kinetic energy and stored energy, that is quote-unquote mechanical energy. So an object can have mechanical energy at a given time. Your roller coaster, in the middle of its descent, has both kinetic and stored energy. Therefore, it is considered to be mechanical. Okay? Stored and motion. Think of a girl jumping, or a boy, jumping off a diving board. Okay? You get ready to jump. You get a lot of stored energy. You spring off the board. You're in the air. You still have potential energy. And as that descent starts happening, your kinetic energy, your potential energy is moving into kinetic energy. Okay? So again, mechanical energy can happen in the same scenario. So keep that in mind. But it's a good way to be able to describe, okay, describe what is actually most, the same, and the least. Kinetic energy and potential energy are related. It's an indirect relationship. As one increases, the other decreases, okay? As one increases, the other decreases. In science, we label that as an indirect relationship. If one was increased and the other increased, that is a direct relationship. So when we're graphing and we get to that next unit with forces, we're going to start labeling indirect relationships and direct relationships. You're going to do great at it. No worries. Okay? Let's talk about the types of energy. Really what we're going to focus on is 7. Now this is moving beyond the standard, but I know y'all can handle this. Okay? You'll see a lot of this in 7th grade, so I want to go ahead and prep you so you can already do level 4 work when you get there. Okay? Let's talk about radiant energy. Radiant energy, aka light energy, okay, same thing, comes from the sun or any type, or the electromagnetic spectrum. And I know you heard that before from 5th grade. Let's talk about the electromagnetic spectrum. When we see visible light, Okay, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, Roy G. Biv, okay? That's a small portion, okay, of a rather large electromagnetic spectrum. Your electromagnetic spectrum, it can have gamma rays, it can have X-rays, it can have infrared light, okay? All different objects or humans, mammals, see different types of light, okay? As humans, we see the visible spectrum. Again, a very small portion, okay? So radiant energy, light energy, is one type. The next is chemical. Chemical energy is a stored energy. A good example of chemical energy is a battery. Inside that battery, if we were to crack it open, now we wouldn't really technically do that, it would explode. But in reality, if we were to look inside, it's actually a cell. Okay, in that cell, ions are flowing back and forth between two electrodes. I know, a lot of chemistry, Miss Kennedy's favorite. Okay? But there's a lot of stored energy between those ions, and it goes from one side to another. Eventually, those ions get tired of moving from one side to another, and one side gets built up, and no other ions are being produced. Therefore, your battery runs out, and you have to replace your battery. Okay? These are called electrochemical cells, just to let you know. All right? Chemical energy also happens in our tummies. Okay, when we digest food, we've got some acid in our tummies that's actually digesting the food in there to produce bile, etc. We know we all go to the bathroom. Everybody poops. I hope you've read that book. Okay. Electrical energy. Electrical energy. Think about the storm we just had, okay? Why didn't we have electricity? Well, the wires were down, folks. Okay? So our energy couldn't be transferred. That generator station, okay, that was the power plant or whatever was producing that energy, couldn't transfer that energy through the wires to our homes. All right? So we needed some type of conductor. Nuclear energy. Nuclear energy comes in the form of fission and fusion. This is extra stuff that you need to know, but some people are interested. Fission is a type of reaction, as is fusion. Again, chemistry, my wheelhouse. Okay? At our nuclear power plants, okay, you have fission, okay, when you have your radioactive isotopes, for example, lead, radon, anything that's radioactive, technically that can be a cancerous agent, okay, these actually are fission reactions. So what's happening is you have this atom, and it's breaking apart into another atom, and then this atom breaks off into two, this one 3, and it keeps breaking off, and it's considered a chain reaction, so a fission reaction. Fission, division, okay? Another type of reaction is fusion, and that's when you take two atoms and you force them to come together, a positive side and a negative side, and they want nothing to do with one another. So imagine a magnet. When you force those and you feel it between the two magnets, when you force them and you know that it's like moving your fingers, a really strong magnet, that's like that's a fusion, a way fusion sort of kind of works. And we force those atoms together, and a byproduct of that is a huge explosion. An example would be a hydrogen bomb. Okay? Thermal energy. Thermal energy is anything to deal with heat. Okay? So when we feel heat, what that's actually a result of has to do with the kinetic energy, not potential energy. Well, there is some in there. It's mechanical, actually. But kinetic energy of those atoms moving around. Really, what thermal energy has to do with is the way atoms move within a substance or a given object, okay? So let's take water for our example. Say you have H2O. Now, we know a block of ice, okay, is solid H2O. Those atoms within there, the H molecules, okay, the H atoms, the hydrogen atoms, and the oxygen atoms are very tightly together in those bonds, very tight with one another. Okay, slowly what happens is that the energy, it absorbs energy from the atmosphere, and that solid starts melting, okay? And because of that melting procedure, what happens is those atoms start moving around, causing flow. Think of H2O as a liquid, or water, which we define in our bathtub. Think about the flow of a liquid. So they're not as tightly packed. There's more flow, fluidity, okay? Eventually to where if we were left to a cup of water sitting out for days, the water would disappear. It evaporates. So you have water moving to the actual gaseous form, okay? So H2O molecule, same molecule, but it's moved to a gaseous form. Solid, liquid, gas. That's what thermal energy has to deal with, is the way the atoms within that molecule are moving, okay? Lots of chemistry stuff. You learned this in 8th grade, just to give you rest your brain assured that you're going to know this stuff. And finally, sound. Sound energy is you listening to me right now. I know. So it has to do with the vibration of particles within matter. And again, that's what our eardrums are doing, okay? So big picture here, we need to know the types of energy. These energies, this type of energy is going to make transformations in order to obey the law of conservation of energy, okay, which will be my next encounter. So I will attach the 2 documents that I gave for my encounters I did in the class if y'all want to practice those foldables. If you have any questions, just Edmodo message me. And I hope you have a great weekend. Talk to you soon.